Hello everyone. As promised, I'm going to show you how the electrical potential simulation works. So as I go along, I'm going to read the instructions in the Word file, from the Word file that I've posted on Blackboard. So the first thing we have to do is to explore by placing a 1 nanocoulomb positive point charge in the middle of the screen. So you see the 1 nanocoulomb point charge here at the bottom of the screen. It's the red one, so you just click on it and you move it there, you move it to the middle of the screen, and you can already see the electric field vectors everywhere. Okay, so these are the electric field vectors. All these arrows, they are pointing outward, away from the charge, as they should, of course. However, the bad thing with these arrows is that their lengths are not proportional to the magnitude of the electric field, as you can see, because they all have the same length, so they just show you the direction of the electric field and not its magnitude. All right, but there's a way of getting also the magnitude, as I will show you later. Okay, towards the end of the instructions. All right, so however, the amount of light, you can think of the amount of light, of the amount of brightness around the charge, as the magnitude. Okay, that's another way of thinking about the size of this electric field. If it's bright, then the electric field is large, and if it's darker, then it's smaller. Okay, it's smaller. The electric field is smaller, and very far away, of course, it's very dark because the electric field is very small, far away from the charge, which makes perfect sense. Okay, or you can remove that convention of brightness and darkness to show the size of the electric field by showing the direction only. Okay, pressing by checking this direction only option. Okay, so whichever way you want. So now, move the voltage box to different locations near the charge. So this is the voltage probe box, and you see that it changes. Okay, the voltage changes as you move the box to different locations around the charge. Okay, right? You see that the numbers change. Okay, these V is in volts. Okay, so what's the next step? How does the voltage number change? So what do you think? When I bring the voltage probe box closer to the charge, how do the numbers change? When I move it away from the charge, how do the numbers change? Okay, do they ever become negative? Are they always above zero? Do they ever become zero? Okay, those are the kind of questions that you can explore. Okay, the next thing to do is to replace the positive point charge with a negative point charge. So to remove the charge, you have to drag them back into their box. So I take the positive point charge. Okay, I click on it and I drag it back into. So see how the magnetic field vectors change as I move my point charge. Okay, everywhere across the screen. Okay, so it's quite nice, quite interesting. So I'll take it back to the box now, and I bring in the negative point charge. Put it in the middle of the screen. It has so the charge is minus 1 nanocoulomb, and as expected, all the vectors point towards it. The vectors here, of course, show the electric fields. These are electric field vectors. Okay, so they all have to point towards the negative point charge, and then we can show try to show the magnitude by removing the direction only. So where there is more light, the electric field vectors is supposed to be larger, and where there is less light, then it's supposed to be smaller. Now, so how does the voltage probe box show? So how does it? So the probe box, voltage probe box, when you move it, how does it change? How do the numbers change? Okay, as you move it closer and as you move it farther away. Okay, how do the numbers change? I have negative numbers here. Are they always negative? Do they ever become positive? Do they ever become 0? Okay, so those are the kind of questions that you have to answer. All right. This voltage box, what is it probing exactly? Well, it's showing you the voltage at every point on the screen. The point in question, for example, here is the point indicated by the crosshairs. You see that? So the point I'm pointing to here with the index finger of my cursor. Okay, so all right. So what's the next step? Now, how is it the same with the case of the positive charge? So basically, these numbers, when we had a positive charge in the middle, how are they different, or how are they the same with the numbers that we have now that we have a negative point charge in the middle of the screen? So that's what the question is. Okay. So here already I can see negative numbers. We had positive numbers before with the positive point charge. So that's one thing you can talk about. But are these negative numbers always going to be negative? Are the positive numbers all, when we had a positive point charge, always going to be, were they always positive? Okay, so those are the kind of things that you can think of, or you can investigate by moving the voltage probe box in different places. Alright, so the next thing to do now, electric potential is a characteristic of the distribution of source charges. So here they are just defining the electric potential. So it expresses the work a source charge distribution does on a point charge as the point charge's position changes. So this is a definition that you already know from your physics courses. Okay. And then you are given the definition of the electric field, okay, which you already know. Okay, it's related to forces. And then we have the equipotential meter. So here is the equipotential meter. Okay, I can take it and move it. Okay, here for example, if I put the orange plus sign, or the orange cross, on top of the charge, and then move. Let me show you how we can do this, and then move the cross on the right hand side of the meter. See how I'm moving it? Then I can determine the distance between the point that I'm interested in, which is this point in the crosshairs of the voltage probe box, and the charge. So the distance between the point I'm interested in and the charge. What's the distance? Here I'm reading 243 centimeters, which is 2 meters and 43 centimeters. So what the voltage box tells me is that the voltage at that distance is minus 3.704 volts. All right. Okay. So pretty sure you understand that. So now we are asked to read the maximum value, okay, of the voltage on top